This is Chapter 10, Section 2, Areas of Trapezoids, Rhombuses, and Kites. Our learning objective is I will find the area of a trapezoid, rhombus, and kite. We are going to start out with this lovely approximate area of Nevada. And what I've done is given you the area of a trapezoid is 1/2 times the height times the bases added. So the sides that are parallel to each other are the bases, and the distance from base to base is the height. And it does not matter which one is base 1 and base 2, because the addition property of equality says I can add one to the other in any order. That's not what it says. So, commutative property. Okay, so if I say that 309 is the height, 205 is one of the bases, and 511 is the other base. I'm going to substitute all those into my equation. I get 1/2 of 309 times 205 plus 511. When we simplify that down, we get 110,622. And if I put a mile squared next to that, that is the approximate area of Nevada. So here's where we get a little shifty. For those of you guys who thought we could learn about 30, 60, 90, and 45, 45, 90 triangles and then just forget everything about them, this is where that comes back to us. All right, so we want to know the area of this trapezoid right here, PQRS. The two bases are 5, and they don't give us anything except that this angle is 60. So if on your diagram you want to put in that vertical height, which is going to create a nice little 90-degree angle. So we're kind of splitting our trapezoid up into a triangle and a rectangle. What we end up having here, this is 60, this is 90, this one has to be 30, and 30, 60, 90 triangles have special relationships between their sides. So you have your short side, which we call S. You have your long side, which is S times the square root of 3. And you have your hypotenuse, which is 2 times S. So if this distance from here to here is 5, and this distance from here to here is 7, what is this guy right here? What is the distance from P to, we'll call this QRST. What's the distance from P to T? The whole thing is 7. 5 is this little section. This little distance has to be 2. So we take this S and we can replace it with 2. So instead of S root 3, we have 2 root 3. Instead of 2S, we have 2 times 2 times root 3. Yay! So our height is actually equal to 2 root 3. So now we have all of our components to put together our formula. So when we found the longer leg is equal to the shorter leg times the square root of 3, we did that. Okay, so now we have the trapezoid formula. So we are going to substitute in 2 root 3 for h. So we got 1/2 times 2 root 3 times 7 plus 5. 7 plus 5 is 12. 1/2 of 2 root 3. Well, half of 2 is 1, so that's root 3. So we have 12 times the square root of 3. So the area of the trapezoid is 12 times the square root of 3 meters squared. What is the advantage of not chugging that into the calculator? Why did they leave it as 12 root 3 instead of pushing it through their calculators? Saving you from writing all the decimals because it's an irrational number, so the decimal will go on forever. All right, let's see if we got this. We have a triangle that is PQRS. Instead of a 30, 60, 90, we have a nice little 45, 45, 90. So just to remind you of what our 45, 45, 90s are. If we have a side here, it's also equal to the side here, which is equal to the side times the square root of 2. Thankfully, we have the same scenario. I have 5 on top and 7 on the bottom. What does that leave us for this distance right here? Same as the one before. Before, what plus 5 is 7? 2. 2 plus 5 is 7. So now I have this nice little triangle, 45, 45, 90. This is 2. This is 2. And that's all we need. So the area is 1/2 the height times the bases added. Let's substitute in a 1/2 times 2. That's our height. And then the bases added is 7 and 5. Half of 2 is 1. 7 plus 5 is 12. So the area is 12 meters squared. So just so that you guys remember, a kite has 2 pairs of consecutive congruent sides. The formula for the area of a kite is the diameter times the diameter times 1/2. Sorry, the diagonal times the diagonal times 1/2. That's the diameter. Brain's not. Okay, so to find the area of the kite, you need its diagonals. So what they did to find the diagonals was go 2 plus 5 makes a diagonal of 7, and 3 makes a diagonal of 6. So we just put that into our formula. 1/2 times 7 times 6, and we get 21. The area of the kite is 21 meters squared. Did you guys get all that? All right, so when we want to apply that to our problem here, I always draw the picture because it kind of allows my brain to sort in. These diagonals are 12 inches and 9 inches. So the formula for area of a kite is 1/2 diagonal times diagonal. Half of 12 is 6. 6 times 9. 54. And that would be inches squared. All right, next problem, we're going to find the area of a rhombus. So the high occupancy vehicle lane is marked by a series of diamonds or rhombuses painted on the pavement. What is the area of the HOV lane diamond shown at the right? So if you guys are copying this down, it's a nice diamond shape. It is a rhombus, so all the side lengths are the same. That's 6.5 feet, and across here, this is 2.5 feet. This is 90 degrees. A. Okay. So we need to use the Pythagorean theorem because we want to find our base of our. Hold on. So we're going to solve for AB, and we do that by taking AC, which is our 6.5, minus BC, which is our 2.5. So it's taking the information that we have using the Pythagorean theorem to find our distance from here to here. So the million-dollar question is, what is the formula for the area of a rhombus? And it's the same as a kite. So our goal right here is we're finding the diagonals. We already know that the diagonal here is 2.5 plus 2.5 is going to be 5. And we just found our long ways diagonal, which, so this diagonal right here is going to be 5, and this diagonal right here is going to be 6 plus 6, which is 12. So 1/2 times 5 times 12 is 1/2 of 60, which is 30, so the area of the diamond lane is 30 square feet. Okay, let's see if we can apply that to this problem right here. A rhombus has 10 sides 10 centimeters, so I'm going to draw my wonky rhombus. He's 10 on each side. And then the long diagonal is 16. So 1 and a 6. What is the area of the rhombus? Well, we don't know yet because we do not have short diagonal. But we do have, if the diagonal is 16, half the diagonal is 8. So if we take this little triangle here, we got 8 and 10, and we are going to use Pythagorean theorem to find x. We get 8 squared plus x squared equals 10 squared. And we subtract 64 from both sides. We get x squared is equal to 36. Square root of 36 is 6. So this guy right here is 6. 6 plus 6 is 12. So the other diagonal is 12. So now we go, the area is 1/2, 10 times 12. Half of 120 is 60. So just to reiterate, we found this was 16, this is 6, and this is 6, so this diagonal is 12. No. Not 10. What's the diagonals? What are the diagonals? What's the diagonal? Not 10. 16.
45.
Diagonal is not 45. So if we go, half of 16 is 8. 8 times 12 is 96. And that means I am glad I put the multiple choice answers up here to keep me from making a really big mistake. All right, so that is diagonal of a rhombus.